2017 probability questions. Connor rings Kira's house. The probability that she answers the phone is 1 over 5. Anytime they give us a probability, match it off with the probability of her not answering, or whatever the other side of the question is. So 4 over 5 is the probability of her not answering. So he rings her house every day for 7 days. Find the probability that she will answer on the 2nd, 4th, and 6th days. Now, you could confuse this with a Bernoulli trial, which is the next part of the question, but this is something happening on every day, just one thing happening in a particular order. So we have 7 days. Let's do 7 circles. 1, 2, 3, 4, 5, 6, and 7. And the probability that she answers on the 2nd, the 4th, and the 6th. So that's the 1 over 5s. The 2nd, the 4th, and the 6th. So you can see all the others are going to be 4 over 5. So it's a straight multiplication. So let's just jump up here for the multiplication. We have 4 over 5. We have 4 of them. So 4 over 5. That's 4 to the power of 4 over 5 to the power of 4. Multiplied by 1 over 5. We have 3 of them. So 1 over 5 to the power of 3, or 1 over 3 by 5 to the power over 5 to the power of 3. Now 4 to the power of 4 are 64 fours, which is 256. And 5 to the power of 7 begins with a 7. It's 78,125. So that's the answer to part 1. Part 2, you'll see the difference now with a Bernoulli trial. Bernoulli trial is something specific happening on a particular day, but we don't know what has happened on the previous days. So circle what we have here, the 4th time on the 7th day. So what we're looking at is the first 6 days. Now she could have answered the phone. She's answered the phone 3 times in 6 days, but we don't know, and this is 6 NCR 3, we don't know what days they were. So that's why we have to use NCR here, because it could have been day 1, 2, 3, 1, 2, 4, 1, 2, 5, and so on. And what we always do with these questions is we multiply by the probability of success to the power of this number. She's answered the phone 3 times, so that's 1 over 5 to the power of 3. And the probability of failure, which is also 3, she didn't answer the phone on 3 days, so 4 over 5 to the power of 3. And then we multiply by what's happened on that 7th day. She answers the phone on the 7th day, so that's 1 over 5. So what does this work out to be? Let's just move a little bit to the side. Okay, so we know that 6 NCR is 20. Just come up here, 20, 6 by 5 by 4 over 3 by 2 by 1, the 6 and the 3, 2, 1 cancel. 5 by 4 is 20. What do we have on top? We have 1 cubed by 4 cubed. Well, 1 to the power of 4 by 4 cubed, so 4 cubed is 64. On the bottom again, it's 7 days, isn't it? So we're going to have 5 to the power of 7 on the bottom. So that's going to give me 1280 divided by my 5 to the power of 7, which is 78,125. So that's the answer to part 2. Now part 3. Connor rings our house every day for n days. He's fairly persistent, this Connor, in ringing. Write in terms of n the probability that Kira will answer the phone at least once. Well, this comes back to some of the things we've seen already in these probability videos. At least once is 1 minus the probability of never answering the phone. Now, what's the probability of never answering the phone? 4 over 5 is the probability of never answering the phone on the first day. The second day, be 4 over 5 to the power of 2. So n days is 4 over 5 to the power of n. So 1 minus the probability of 4 over 5 to the power of n is the probability that she will answer the phone at least once. So moving down, find a minimum value. I'll leave this one here because we're going to need it. Find a minimum value of n for which the probability that Kira will answer the phone at least once is greater than 99%. Okay, so that's our formula from above. 1 minus 4 over 5 to the power of n has to be greater than 99%. Okay, now I can move this up. Okay, so that's we want, I'll just do an extra step in here. Minus 4 over 5 to the power of n, if we bring the 1 across, it's going to be 99 minus 1, or 0.99 minus 1 minus 0.01. So we know if we change signs within inequalities, what are we going to have to do? We're going to have to reverse the symbol. So 7 is less than 10, but minus 7 is greater than minus 10. So if we multiply by minus 1, we need to reverse that symbol. So 4 over 5 to the power of n is going to be less than 0.01. Now we're using our rules of logs. N by the log, I'm going to change it to 0.8 just because the other one's a decimal, less than the log of 0.01. Now the log of 0.8 is negative, so again we're dividing across by a negative, so I'm going to need to reverse that symbol again a second time. So n has to be greater than the log of 0.01 divided by the log of 0.8. If you type that into your calculator, you're going to get 20.63. So if n is greater than 20.63, n would have to be equal to 21. Okay, the heavy rainfall, heavy traffic, rain, late, Galway question with loads of words in it. Maths involved is straightforward enough. The rain falls on a third of the school days in a year in Galway. Now, if you're from Galway, you know that that's probably a massive underestimation. It rains every day in Galway. When rain is falling, the probability of heavy traffic is 1 over 2, which is another lie because heavy traffic in Galway is just a constant, but let's just take it as 1 over 2. When it's not raining, the probability of heavy traffic is 1 over 4. And we're going to see these are given to us already in a tree diagram that was given to you in the question. So 1 over 2, let's just match these off down below, 1 over 4. When it's raining and there is heavy traffic, the probability of being late for school is 1 over 2. When not raining and no heavy traffic, the probability of being late for school is 1 over 8. And in any other situation, the probability of being late for school is 1 over 5. So 5 fractions are given to us. So let's have a look down here. 1, 2, 3, 4, 5. We can see the 5 things in blue here were all given to us. So it's just a matter of filling in. Everything in blue is given. So let's fill in red what wasn't given. Now we know all these. If it rains a third of the days, it doesn't rain on 2/3 of the days. Come up to the top here. If it rains this half here, we'd have to have a half down here to make up our 1. Similarly, we'd have to have a half here to make up a 1 with this half. This is the 5th that was given. Just make it a bit clearer. That was the 5th that was given. So 4/5 is the opposing side of that. They give me a 1. Here we have a quarter. So this one would have to be 3/4. So I've left out a couple of things here. What else did they give us? They gave us when not raining and no heavy traffic, the probability of being late. So not raining, no heavy traffic. Not raining, no heavy traffic. I'll do it in blue because it was given to us. Not raining, no heavy traffic is 1 over 8. And I think it tells in all other cases, the probability for being late for school is 1 over 5. So that would give us this 1 over 5 here. And the other late is this one, 1 over 5 here. Just let me flick back to red and we'll fill in what we weren't given. So this will be 4 over 5. This one here, this is going to be 7 over 8. Is that everything? That's everything. So now we just multiply. Going in this way, well, we'll write all the sums out. This is 1 over 3 by 1 over 2 by 1 over 2, which is equal to 1 over 12. This one is 1 over 3 by 1 over 2 by 1 over 2, which is also 1 over 12. The third one is 1 over 3 by 1 over 2 by 1 over 5. Which is equal to 1 over 30. The next one, the same first two, 1 over 3 by 1 over 2 by 4 over 5, which is 4 over 30. Coming down to the bottom, we have a 2 over 3 by a 1 over 4 twice. 2 over 3 by 1 over 4 by 1 over 5. And then 2 over 3 by 1 over 4 by 4 over 5. And what are they equal to? 2 on top and 60 on the bottom. 2 over 60 or 1 over 30, whatever you prefer. Now we have 8 on top, 2 by 4 and 60 on the bottom. 8 over 60, which is 4 over 30, 4 over 30 or 2 over 15. Coming down to 3 over 4. So we still starting with 2 over 3. 2 over 3 by 3 over 4 twice. And the last probabilities are 1 over 8. Multiply, not equals 1 over 8 and 7 over 8. So that leaves, just so we can see the number, 2 over 3 is 6 and 3 fours are 12 by 8 is 96. 6 over 96, which is 3 dividing 2 over 48, which is 1 over 16. And on top, 2 3s are 6 by 7 is 42 over 12 by 8 again, 96. 21 over 48, which is equal to 7 over 16. Okay, so we were asked on a random day in Galway, we were asked to fill in the tree diagram, and then on a random day in Galway, the probability of being late. What do we have? We 4 of them, 1, 2, 3, 4 that we need to add together. We've got a 1 over 12. We have a 1 over 30. We have a 1 over 30 again, just double check. Yeah, 1 over 30 again. And the last one is a 1 over 16. And my calculator for this one is going to give me 17 over 80 is what the fraction comes out as. What's that as a decimal? 0.2125. Now the next part of this question is a conditional probability question where we'll use this answer. So it says, on a random day in Galway, find a probability that if it rained, find a probability that it rained in the morning given that you are late. So let's have a look back up. Find a probability that it rained in the morning given that you are late. So that's the top one, the rain in the morning. And here's the two lates. So it rained in the morning given you were late. We're going to look at these two. That's the intersection between raining in the morning and late. These two. And the answer to the second one is the probability of being late. So how does that one work out? So it's a conditional probability. Conditional probability, which you may have looked at that video. If you haven't, go and look at it. So we're going to get the two lates. Just double check them. 1 over 12 plus 1 over 30. Divided by the probability of late. This is the intersection of the top part. Raining and being late. And what do we get for that one? 17 over 80. And if you type that into your calculator, it's giving me 28 over 51, which is 0.549. So a kind of awkward question, the amount of words in it, the amount of fractions to multiply, but take your time. Any of these questions, take your time, double check all your calculations, and you should be fine.